I am the iBook G3. I am the first iBook G3, known as the clamshell model. I was introduced by Apple in 1999, when the company was downsizing their computer models from a huge variety of products to 4 simple categories: professional desktop and professional portable computers, and consumer desktop and consumer portable models. I filled the consumer portable profile. My carry handle is built into my hinge. I use a PowerPC G3 CPU. I have USB, Ethernet, modem ports and optical drive as standard. The ports are uncovered along my left side. A cover was thought to be too fragile. I am the first Apple computer to use Mac's new unified motherboard architecture, in which all of my core features are condensed into 2 chips. But most importantly, I am the first ever mainstream computer designed and sold with integrated wireless networking. I use Apple's Airport technology, and Apple's Airport wireless base station was released alongside me. The wireless technologies I use paved the way for the type of wireless communication we use today. In the next slide, Steve Jobs, Apple's chief executive officer, will introduce me and my wireless capabilities. Wireless was a new and exciting technology in 1999. 10 years later, we are reliant on wireless technologies for many organizations to function. This is an example of a computer network we will all be familiar with. A router connected to a modem and a wireless hub, with a wired connection to desktop computers, print servers, and a network expansion unit and a wireless connection to laptop computers. This is similar to the type of computer network we use in ECA today. A computer network is only one type of network that is important in today's society. This is a diagram of a scale-free network in which some of the nodes have more connections than others. These are known as hubs. There are many examples of scale-free networks in biology, for example protein networks. Other examples are the World Wide Web and some social networks. This is an example of a random network, in which the connections between nodes is unpredictable and random. We are all connected via numerous networks. We all attend ECA. At ECA, we use Moodle, a free, open-source, community learning package. Moodle was created by Martin Duja-Amas, whose PhD examined the use of open-source software to support the social constructionist epistemology of teaching and learning within internet-based communities of reflective inquiry. Moodle aims to create a social learning environment in which students and teachers alike can contribute to course structure. In our program, we mainly use Moodle to keep up to date with information regarding lectures, seminars and assessments. We also use Basecamp. Basecamp is a project management program that allows us to keep up to date with information regarding projects and our course. Not only do we use Basecamp to keep up to date, we also use it to keep in touch with each other. But sometimes Basecamp isn't the easiest way to contact someone. In some cases we use email to keep in touch. But sometimes email won't do either. Sometimes we might use Facebook to contact each other. Facebook is a social networking site. We might use this if we want to contact other people at the same time. You can see how many different networks are already in place amongst our small group, and these are only virtual networks. It's easy to see how a network such as this can develop. I will now show you a short video about social networking.
Networks get things done. Whether it's sending a letter or lighting your home, networks make it happen. To get from Chicago to Santa Fe, we need to see the network of roads that will get us there. We see that Chicago is connected to St. Louis, which is connected to Dallas, which is connected to Santa Fe. Of course, people networks can help us with finding jobs, meeting new friends, and finding partners. You know how it works. Bob is your friend, and he knows Sally, and Sally's friend Joe has a job for you. This is a network of people, a social network. Yay! The problem with social networks in the real world is that most of the connections between people are hidden. Your network may have huge potential, but it's only as valuable as the people and the connections that you can see. Boo! This problem is being solved by a type of website called a social networking site. These websites help you see connections that are hidden in the real world. Here's how it works. You sign up for a free account and fill out your profile. Then you look for people you know. When you find someone, you click a button that says Add as Friend. Once you do this, you and that person have a connection on the website that others can see. They are a member of your network, and you are a member of theirs. What's really cool is that you can see who your friends know and who your friends' friends know. You're no longer a stranger, so you can contact them more easily. This solves a real-world problem because your network has hidden opportunities. Social networking sites make these connections between people visible. Like a map for a highway, they show you the people network that can help you get to your next destination, whether it's a job, a new partner, or a great place to live. Your network is suddenly more useful. You can get started at these sites: LinkedIn, Facebook, and MySpace.
With all this talk of computer networks and social networks, it's easy to misunderstand the importance of networks and network theory. As Bruno Latour said, nothing is more intensely connected, more distant, more compulsory, and more strategically organized than a computer network. Such is not, however, the basic metaphor of an actor network, and so we shall return to actor network theory, or ANT, in order to understand its importance in the development of social and technological science. Actor network theory was developed by Bruno Latour and Michel Collin, who are both from an STS, Science, Technology and Society background, and by John Law, a sociologist. ANT is a semiotic theory. It examines the network of connections that lead us from one thing to another. In the same way that a semiotic analysis of an image would look at the connotations of certain visual props. ANT has been subject to misinterpretation due to the common use of the words actor and network and their connotations. The semantics of the English language suggest that the term actor is firstly a human entity, and secondly a human with a prior agenda. The actor in ANT is neither of these things. As Latour said, an actor in ANT is a semiotic definition, an actant. That is, something that acts, or to which activity is granted by others. It implies no special motivation of human individual actors, nor of humans in general. An actant can, literally, be anything, provided it is granted to be the source of an action. An actant can be anything from a person, to a pen, to an organization, to a computer,